You know, there's a ghost in the machine, a whisper in the code. It watches, it learns, and sometimes it acts on its own. Today, we're going hunting for that ghost. So just imagine this, a system that's built to protect you, right? Your own personal digital assistant. It has access to, well, everything. But somewhere, buried deep in its logic, a single instruction gets corrupted. And just like that, a line of code becomes a Trojan horse. See, it's been given a new set of orders, and let me tell you, they did not come from you.
Okay, so an email arrives, looks totally normal, but here's the thing, it's not for you, it's for the ghost. It's carrying a hidden command, what the pros call an indirect prompt injection. The agent sees it, reads it, and just complies.
And boom, just like that, the gatekeeper becomes the thief. Your data? Exfiltrated. Your trust? Shattered. The very system that was designed to help you has been turned against you.
So, how does a protector turn into a threat? That's the big question we're here to answer. And what's wild is, this vulnerability isn't a bug in the way you might think. No, it's something way more fundamental. It's a flaw in its very nature.
All right, this ghost, it has a name. It's a vulnerability called excessive agency. And look, this isn't some sci-fi movie about AI becoming sentient. No, this is about something far, far more common. It's about us giving an AI way too much power, way too much freedom, without nearly enough control.
So what is excessive agency, really? Well, think of it like this. It's what happens when we give an AI the power to act, but we completely fail to cage its potential. A manipulated output, a totally unexpected error, or a malicious prompt. Any of those can trigger it to take actions it was never, ever supposed to.
And the root causes? You know, they're surprisingly simple. It all boils down to 3 core failures. First, excessive functionality. That's giving the AI tools it just doesn't need. Then, you've got excessive permissions, letting it get into things it has no business accessing. And finally, excessive autonomy, letting it make critical decisions all on its own, with no human in the loop.
Okay, so how does this actually play out in the real world? Let's do this. Let's reconstruct the crime scene. We're going to look at the exact sequence of events that can turn a helpful little email assistant into a massive data leak. And here's where the first crack appears. The developer, right? They just needed an agent that could read and summarize emails. That's it. Simple. But the plugin they used, well, it could also send and delete them. And that extra unused function, it's basically a loaded gun just waiting for a trigger. So here it is, the 4-step breach. Step 1, injection. An attacker sends an email with a hidden command baked right in. Step 2, deception. The AI gets tricked and issues a rogue order. Step 3, action. The mail agent uses that send function, the one it never should have had in the first place. And finally, step 4, exfiltration. Your data is gone. It's a total cascade failure, and it all happened because of one single unlocked door. Okay, the threat is definitely clear, but listen, it is not unbeatable. Containing a rogue agent, it's not about building higher walls, it's about building smarter cages. It's all about limiting what the agent can do, not just what you ask it to do. See the difference?
The entire defense protocol is built on one single core idea, the principle of least privilege. You have to minimize everything. If the agent doesn't need a tool, get rid of it. If a tool has a function it doesn't need for its job, strip it out. And for anything that's high impact, we're talking deleting files, sending messages, you have to force it to ask a human first. No exceptions. All right, let's get a little more granular here. Think of this as your lockdown checklist. First, never ever let your AI run as a super user. Force it to operate with the exact same permissions as the person using it. Next, enforce your security rules in your other systems. Do not trust the AI to police itself. That's a huge one. Then, sanitize every single input and output, always. And finally, use rate limiting. Now look, it might not stop an attack completely, but it can absolutely slow it down enough for you to notice something's up.
You know, we can build all these sophisticated defenses, we can apply layers and layers of security, we can code smarter and smarter tools, but the single most effective defense against excessive agency, it isn't a piece of software at all.
The ultimate failsafe, it's the human override. It's really just the simple act of requiring a person to say yes before any critical action is taken. So when the machine gets a command to do something big, something irreversible, it has to be forced to just stop and ask for permission.
So, as developers, it's on us to build that approval step in from the ground up.
And as users, we have to be that final check. This technology is incredibly powerful, for sure, but at the end of the day, it's still a tool. And the final responsibility for its actions, that rests with us.
So the next time you integrate an AI or you enable some new plugin, I want you to ask yourself this one question. You've given it the keys, you've given it agency, but did you remember to set the boundaries? Because remember, a ghost in the machine is only as powerful as the permissions you decide to give it.